Welcome to the Software Process and Measurement Cast number 606. I'm Tom Kegley, your host, and the SPaMCAST 606 features our interview with Marco Faella, author of Seriously Good Software, Code That Works, Survives, and Wins. Marco and I discussed quality, craftsmanship, and how being a passionate coder and an academic mix. Marco Faella teaches advanced programming at a major Italian university. His published work includes peer-reviewed research articles, a Java certification manual, and a video course on Java streams. Are you ready to talk seriously good software? It's time for the interview. Marco Faella, welcome to the Software Process and Measurement Cast.
Thank you very much.
Marco, you are the author of Seriously Good Software, Code That Works, Survives, and Wins. It's a real honor to have you on the show, and as I got a preview copy, I was reading through the book, so I'm prepped and ready to go. Can we dive right in and just let's tackle sort of the whole idea of what is seriously good software? What did you mean by that?
Right. So maybe this is going to sound a little tautologic, not very deep, but basically, I think seriously good software is any software that's well thought out. So it comes after deliberation. It's not just the first thing that works, the first thing that satisfies your functional requirements. And in my mind, to get this good software, you have to have these two steps. So first, you have to be somehow aware of the alternatives. So aware of different ways to write your software, of different ways you could have written your software, both at a high level, architectural level, and at a more small scale level, which is the one I address in the book. So, and then after you're aware of the alternatives, of course, you have to judge which is the best one. You have to pick one. Obviously, without getting stuck in the famous so-called analysis paralysis. So at some point, you have to make a deliberation and pick one. And so in the book, I'm mostly addressing the first part. So the awareness stage. So even like before the analysis part, you at the very least you have to be aware of other possible ways to do that, to achieve your goals. And that's why in the book I show many different ways to develop the same simple class, simple example, to show especially to inexperienced programmers that there's a really wide variety of ways to solve even a small programming problem.
Do you feel that education in the software world doesn't prepare new programmers, new coders for being able to be aware of different possibilities?
Yeah, I think it's not one of the strong points of formal education. So I'm mostly familiar with computer science, with academic education, and in universities, I believe most of the time you go very much in depth in a number of different technical and useful and fundamental topics. But on the other hand, you have a few occasions to connect the dots and compare like algorithmic strategies with, compare like performance requirements with readability requirements or maintainability requirements, and contrast them and figure out what's the best compromise.
The whole idea of non-functional requirements is, at least for the developers that I deal with, isn't always the first thing that's on their mind. So,
Sure.
So they tend to drop those. What would be an approach in your mind to making sure that developers at least weigh non-functional requirements? Because if you don't tackle the non-functional requirements, I don't think you can get to seriously good software.
Right. It's very tricky. It's a very hard problem. Let me make an example. So I guess the answer depends on which kind of non-functional requirements. So, for example, there's some non-functional requirements like performance. Those are relatively easy to get into the developer's mind. It's quite natural, I think, for most developers to think of performance, even if it's not specified as a formal requirements in their specifications. It's quite natural for developers to think about it and to be concerned about it. On the other hand, something like readability is usually gets little consideration from most people. So, what would I suggest to make developers care more about readability? Well, the word somehow says it all. Make them read more code. So, well, I mean, on the job, they're probably going to read a lot of code anyways, but help them pay attention to the fact that sometimes reading other people's code is easier and is much easier than other times. It depends a lot on how much care that other developer put into their craft and put into their readability effort.
Yeah, readability. Once upon a lifetime ago, I did my time as a maintenance programmer and a tester of maintenance programmers' work, and can remember 2, 3 in the morning when something was broken, trying to decode how somebody had actually written something. So readability became very important to us. It became one of the things that we actually checked in when we did code reviews. So I agree. Unless it's important, one doesn't look for it. The whole idea of writing a book like this, which is, I would suggest, pragmatic and interesting to someone who's working at the code level. So it can really talk to that. You live in most of your life in an academic world. How are these two things related?
So there's different answers, because the academic world and my job have quite different aspects. So there's the research, and then there's the teaching part. So in research, so I'm mostly a theoretician, but still we do develop software tools that are actually very rough prototypes based on our theories. And I can admit very frankly that those prototypes are you really wouldn't want to, I wouldn't want to show them around. They're like hacked together to get your papers published. Like, they're not products, obviously.
Yeah.
So you can have very different standards to commercial software. So that's a different world. And the teaching part instead is very much connected to our conversation, to this book. And in fact, the books come right out of my 15-year experience in teaching graduate and undergraduate students various programming classes. So in my teaching, that's the software qualities are very much present and foremost. So this idea of comparing and contrasting different qualities and putting and stressing, highlighting the importance of non-functional requirements comes directly from my teaching.
When we were having our conversation before the interview, one of the things that came across is your passion as a coder. How has that influenced how you teach?
Yes, I've always been very passionate about coding since I was probably 10, something like that. So my dad was he's a civil engineer. So we had computers around since the late 70s, I think. So we had this old HP custom, well, not custom, but how can I say that? They're not PCs, obviously. They're the custom machines. And so I learned to program in BASIC on those machines, and I've been programming since then. Now in my academic teaching, I try to first of all convey my passion and enthusiasm about the craft, and then I try to keep classes very practical, which is not entirely standard in the academia, and in particular in Italy, where like many people complain about university education being far away, being different and far away from practical applications and from the demands of the jobs. Whereas I try to keep the class very practical, so with live coding, and I encourage students to program throughout the class, and we constantly compare our code and the students' code, and things like that.
It's funny that you mentioned that. I was having a Twitter conversation, if Twitter can be considered a conversation, with someone this morning who was lamenting the fact that, at least in CS here in the States, most classes are not taught as team, and therefore, the people that are coming out don't understand how to work together as a team, don't know how to commit code and work together and work through those kind of problems, which are highly pragmatic. So I understand why you would want to take a pragmatic view. So what you're describing is very typical across the globe, at least. You called it a craft. There is an interesting chain that would suggest is what we're doing when we're coding, developing products, things like that. Is that engineering, or is that a craft, or is it some hybrid in between?
Right. So I know that it's not a science. Okay, let's start from one extreme of the spectrum, which is science, which is what I also do for a living in my research time. So it's not a science. There's no rule book telling you how to program seriously good stuff, right? So there's a lot of
book about that. I've heard about that.
That's true. There's one book now, but just one book. There's very little help just from this one book. But seriously, so there's lots of guidelines, and there's lots of experts and lots of different opinions. And so, in my mind, it's really closer to a craft or than anything else. It's really interesting to compare it with other engineering disciplines, like like building something, building a bridge. So the problem with software, and the problem at the same time, the beauty of software is that you have so few constraints. Right? You have so few constraints in the shape and in the structure of your program. Whereas, like in structural engineering, you have gravity, you have earthquakes. Those are hard constraints that you just cannot build around. Whereas in software, well, obviously you have some constraints. You have, certain performance constraints, certain amount of memory, but there's a lot more space there's a lot more alternatives to make something that works, different things that work, but they're still different, especially from the non-functional point of view. So that many different ways to have something with the same functional behavior with very different non-functional profiles.
If we're dealing with something that is closer to a craft, how do we define quality? Is it not like beauty then, in the eye of the beholder?
It's also a little bit in the eye of the beholder. It's like readability. In particular, we mentioned that earlier. It's at the same time very important, but also very hard to measure. I've read people I've read research papers trying to measure readability by monitoring the brain waves of people reading code. I don't believe that's gonna like give us an operational, like give us.
Could you see an MRI machine hanging around, in a bullpen in the middle of an office?
Like, I'm not very optimistic about this hard attempts, like hard science way of measuring things in this particular case of readability. So when you have something that's very important, but somehow subjective, and you have different people have different opinions on how to achieve that, you certainly are in the realm of a craft, of something that, closer to a craft that to an engineering disciplines. And I know many people say that it's due to the fact that computer science is young compared to those other disciplines. And I hope they're right. And I'm not sure, but I hope they're right. And maybe in 50 years, we'll have a much more systematic software engineering curriculum with more of a rule book or something, a more shared vision of quality and more of objective ways to measure it.
Is quality definable?
So there's standard attempts. Like, you can say that quality is the extent to which your product satisfies your client's requirements. That's a very like standard, neutral definition. And one problem with this definition is that most of the time your client is not going to state everything, is not going to state your non-functional requirements. So there's going to be a lot of quality dimensions that are important, but are not formally part of the specification process, and there are often not part of the formal dialogue with the client, such as, once again, we go back to readability all the time, because that's really the perfect example of this. So the client is not going to tell you, I want an easily readable code according to the clean code guidelines. I mean, this is something that us care about, that we engineers care about, but then the client is not going to require that. So you have to have a broad perspective on quality. You don't have to stop at the formal specification, but you have to be aware, once again, of all quality dimensions, including those that do not affect the system behavior right now, but they affect the software evolution, all maintainability, robustness, reliability qualities.
As an academic, how did you decide to write a book that I would assume that it would be easy to walk through any programming shop, and for those who actually have paper still, because we wouldn't be able to see it on their Kindle perhaps, but I would see a copy of seriously good software sitting on their bookshelf versus an academic tome. How did that come about?
So as I said, it came from my teaching experience, because my teaching experience is a little bit unique in compared to other people I know, compared to my colleagues. So first of all, I was given this, I was asked to prepare this class 15 years ago, which is called Programming Languages 2. It's the second programming language class for undergraduates. It's for third year undergraduate students. So, and the problem is, so usually in a programming class, in a programming language class, you compare different programming languages and perhaps different paradigms, and so you teach about what's common and what's different between different structures that you find in different languages. Whereas here in Naples 15 years ago, we had the problem that the students didn't have a standard object-oriented class. Like, they didn't have an OO programming class. Like, they were they were learning C and a little bit of Java, but not really object orientation. So they asked me to do a kind of mix between a standard programming language class and an object-oriented programming class, which is quite a different beast, because in an object-oriented programming class, you usually pick a language and you go deeper into that language. You don't do all the comparisons with many different languages all the time. So I was given this opportunity. I was given a lot of freedom to design it, and so I had fun. I mean, I thought it was perfect for me. I think I'm a very curious person. I like to read and do many different things, many different hobbies, for instance, very different non-technical things. So I had fun designing this class, and it turned out to be very well. I can't say it's very good or interesting, but I can say that students give me very good feedback about it. And so out of this class, after many years of refining it, I thought it was time to put it on paper and share it with a wider audience.
Excellent. Well, I'm glad you did. Marco, if you woke up tomorrow morning, someone handed you your morning caffeinated beverage and a magic wand and gave you 2 wishes, 2 things that you could change that impact the writing of good software, what would those 2 things be and why?
That's a very hard question. So one thing that comes to mind is read more good code. Okay, that doesn't even need. It's a very practical thing. You don't need a magic wand. You just need to convince people.
The problem is, right? It may not need a magic wand, but I'm not sure that I see people focusing on reading, especially other people's good software code, so that they understand what good looks like, so that they can have that conversation. I think spending a wish on that's actually a big deal to me. So I think that would be phenomenal. So you were about to give an example as to what that would look like?
Yeah, for instance, I was thinking of, Java is the language I'm mostly familiar with. So from time to time, I happen to look into the source code for some standard library, like the Java collection framework, which is one of the best parts, one of the most important, useful parts of the Java API. And that's great code. I think it's very instructive for everyone to take a peek behind the scene. And that's open source. That's there for everyone to look at. And I think that's a great educational experience, for example.
What would a second one be?
Second one. So first one is reading it. So perhaps since the first wish is about reading it, the second wish should be about writing some code and having some, or maybe even a panel of super expert developers, like super clean code gurus and expert people look at it and talk to you, and have a special code review personal code review session with a panel of experts just for you. No judgment, not in a work environment, just from time to time. There's a special code review for you to improve your style.
I could actually see that happening either in a physical conference or a virtual conference, and put people behind screens. So there wouldn't be any possibility of attribution. So no, I think that was another phenomenal wish. No, those were excellent. Marco, if people wanted to continue the conversation, how would they find you on the web? How would they go about doing things like that?
Well, there's my personal webpage. There's a couple of pointers there, educational material, even though some of that is in Italian, actually. And I'm on Twitter as the best channel. And then, of course, people actually buying the book, they have the live book. There's this forum, Manning provided forum, where they can comment on specific parts of the books and stuff like that.
Super. Marco Faella, author of Seriously Good Software, Code That Works, Survives, and Wins. Thank you. This was incredibly informative for me. I've got, and I'm an avid note taker, so I've got a page of notes.
Thank you so much.
And a couple of good ideas. Before we go, is there anything else that you would like to promote?
No, I'm just very happy the book is out, and I hope as many people as possible take advantage of it.
I certainly hope so. Again, Marco, thank you very much. This was absolutely marvelous. Thank you.
Thank you. Thank you very much for inviting me.
In Reread Saturday News, this week we are taking a break from our reread of Tame Your Workflow to celebrate the 4th of July and, most importantly, my wife's birthday. We'll be back next week. Remember, buy your copy of Tame Your Workflow, use the link in the show notes, support the authors, obviously, and the blog and podcast. I have some announcements. The Patterns Podcast, something I've been doing with Ben and Wozniki. The first full episode of the Patterns Podcast has been posted on YouTube. There's a link in the show notes. In the first full episode, Ben and I tackled the concept of user stories. User stories are an ubiquitous feature of Agile implementations. We've posted the video on the YouTube channel. We'd love to have your feedback. Please let us know what you think. And I promise not to put 200 plus meg video files on the audio podcast feed ever again. In the very near future, the Tom Cagley and Associates website will be up. Yay! I'm looking to add a newsletter to that, and I have a couple that I like a lot and will be emulating. But if you have a newsletter that you like and think that I should use as sort of input into the newsletter process, please shoot me an email at tcagley@tomcagley.com. Hey, feel free to send a sample. That's cool too. I'm interested in learning how others see newsletters. In the Software Process and Measurement Cast number 607, we'll feature our interview with Mark Tolbert and Susan Parente to discuss their new book, Hybrid Project Management. Agile hybrids are often pilloried. Mark and Susan make a strong case that hybrids have a place in delivering value. If process improvement is a never-ending journey, why do so many people ask, are we there yet?